sites by blood-brain barrier. What it means is, in your brain, you know that there's always blood. There's blood that supplies every single part of the body except for epithelium, right? And your brain is very important. It always needs to make sure that there's a regular supply of nutrients. You remember that because it doesn't store sugar, okay? And there's your blood. But it is very possible that in addition to very precious nutrients, do you agree? It's possible that there may be harmful chemicals that's also in the blood. And if it escaped and appeared here, it can damage your neurons. And you remember, neurons cannot regenerate. So look at what the astrocytes do. Your blood, the capillaries here, how the nutrients leave the blood is through openings or pores. So this blood vessel must have pores. That's how the nutrients leave. And so look at what the astrocytes do. They cover. They cover the capillaries. They cover the blood so that it effectively creates a blood-brain barrier. You understand? Mm-hmm. It plugs it, all those openings, so that what's able to escape are just the precious nutrients, but harmful chemicals hopefully are protected. There are leaks in the blood-brain barrier. It's not 100% foolproof. In areas where the brain makes CSF, there is no blood-brain barrier. We're going to study CSF. That's the cerebrospinal fluid, okay? So there's no blood-brain barrier. In the hypothalamus area, in the pituitary gland, and in your pineal gland, these three brain structures, they actually make hormones. They're endocrine organs. They make hormones, and hormones are released into the blood. So because they need the blood, there's a break there in your blood-brain barrier too. So that's why even though we have the astrocytes, we still have to make sure that we take care of ourselves. Okay? A disadvantage of your astrocytes is this one: repairs damaged neural tissue. I call it a disadvantage is because what it does, it quickly forms scar tissue. So let's say this was damaged and secretes chemicals. Once it's damaged, it secretes chemicals. The astrocytes will sense that and automatically, it very quickly forms scar tissue. They say that in some instances, so long as the cell body was not actually damaged, maybe just over here or over here, there could possibly be a chance for this one to repair. But because this is very quick to form scar tissue, it doesn't allow it. You understand? That's why if they have a stroke, the injury is permanent. Okay? The next neuroglia that I want to take up is the oligodendrocyte. And next to oligodendrocyte, write myelin, or highlight that in your PowerPoint. So look at, this is the axon. Have you heard of myelin? What does myelin do? Yes. Yeah, the myelin sheath. The myelin sheath actually propagates an action potential faster. So it allows you to do activities quicker and not clumsy. Okay? So the action potential of the nerve impulse, action potential, electrical impulse, they all mean the same. So this one here, once the dendrites detect a change, then the cell body detects that, then the axon will fire an action potential so that it can communicate with the next one. If, can you imagine the length of this one? It will take a long time for the action potential to reach from there to here. The myelin shortens the distance because instead of moving this way, this way, this way, this way, what the myelin does is it insulates this part so that when the action potential reaches here, it jumps to the next one, to the next one, to the next one. It will be faster for the electrical impulse or the action potential to reach here.
In essence, is it like a catalyst?
No, it insulates this one so that not really a catalyst, no, because it's just a sheet.
Okay.
But similar, I guess, in function, it quickens it.
Yeah.
Yes, yeah. Yes, yes, very good. What is the composition of this one? It is, can you guess? Protein? No, it's fat. Very good. It is fat. This is why, you know, your nervous system develops the first 5 years of life. This is why when we have children, we don't limit the fat. They need the fat when they're still growing, right? You just want to give them the good type of fat. This is fat. That's why the babies, when they're learning to walk, they're clumsy. It's not completely myelinated yet. And so, if you limit the fat in your kids, it affects their mental development. You need to give them the good fat to myelinate their neurons, to have very good brain. Okay? You heard of MS, multiple sclerosis. So what happens with MS? This one hardens. Sclerosis is hardening, and if it hardens, it's very hard to fire. So you will notice, and it usually affects females from 15 to 45 years old, they say, in temperate climates. Something about the sun, I don't know. And a lot of times there's always a history of previous viral illness, which all of us have had a history of previous viral illness. And does it make sense? Even though it affects neurons, the myelination, it will be more manifest with motor functions. You start dropping things, you just say, I'm just so clumsy, I don't know what's going on with me. Maybe it's the beginning. Who knows? And then you start seeing double every once in a while. So that's very, very distinct of MS.
I have a question about the sun. You said, is it not having enough
Not
sun?
having enough sun is what they say.
Which are there any axons that are not myelinated?
Yes,
Like,
they're
what
called unmyelinated axons.
would- okay.
Naked
What's the
axons.
advantage of that?
You can't have all of them myelinated. You because there are some muscles that you like in the back. There's this one. Sure, this is myelinated, but over here, the ones that you don't need quick response, then they're not myelinated. They all have to come out of the very slender spinal cord. So some of them mixed myelinated, some of them not myelinated.
Wouldn't it kind of stand to reason that sun could help your lipids because of vitamin D being a lipid?
Vitamin D.
Or something?
Maybe I don't know. I don't know why, but they maybe that's a very good correlation. But they really don't know the main reason. Now here, this is another neuroglia, microglia. Sounds like macrophage. So like I said, remember there's breaks in your blood-brain barrier. It's not 100% barricaded. So there's still a possibility that you will have microbes that will enter, cell debris. You have your microglia right there. They process, they break it down, break it down to their components, amino acids, whatever, so that you can recycle it. But at least they're there to protect. They provide immune function. Okay? Next, you have ependymal cells. Next to ependymal cells, you're going to remember CSF. Okay? So here's your brain. And when you open your brain, that will be next after the cat muscles, you will notice that the brain So next week you start with your cat. I think the week after that I'm just going to let you do the brain, everything, let you do everything so that you're prepared already. You have everything that you need. When you open your brain, the sheep brain, there are spaces in there. The spaces are called ventricles. Wherever there's a space there, just anywhere there's a space, you call that ventricle. So there's the brain, you open it, there's a ventricle. And what lines the ventricles, right here, right? What lines it, the roof, what lines it, any lining, is called ependymal cells. Sounds like epithelial cell. Okay? And so wherever, so here, you see, I'm just going to draw this. I'm not a good drawer, but so like there's your brain, there's the spinal cord, okay? And then there's your cavity. So there's the ventricle, okay? There's what lines it are the ependymal cells right here. These are the ependymal cells. And anywhere there's ependymal cells, on top of it, part of the roof, what makes it up is capillaries. There's blood vessels here. These are capillaries. Okay? They're called choroid plexus. You're going to study this. Choroid plexus. This is nothing but the capillaries right here, making up the roof of the ependymal cells, the ventricles. So what's passing, what's present in the choroid plexus? What do you call, what is it? It's a blood vessel. So what must be inside your choroid plexus is blood. Very good, blood. So that's how you make your CSF. Can you picture that? So blood passes here. You familiar with plasma? Plasma is the fluid part of the blood, right? So as the blood passes here, it trickles down, it starts raining through the ependymal cells. That's how you form your CSF. And then the CSF drains. The job of the function of the CSF, number one, it lightens your skull, right? The brain, it lightens the brain. The brain, they say, is about 4 pounds heavy. So why don't you buy 4 pounds worth of bananas and put it on top of your head and walk around all day? That's going to be heavy. But you don't feel the weight of that because of the CSF, okay? So, do you know how your CSF is formed now? There's your ependymal cells, there's your choroid plexus, or it's a blood vessel, right? So can you picture when your heart pumps, the pressure? That's why you need to have normal pressure. What's in the blood? Your nutrients, your glucose, right? So it will pass there and then trickle, right? It will rain to form your CSF, okay? Do you see how important blood pressure is?
So our brain's pretty much sitting in that fluid up there.
It's what?
It's just sitting in that fluid.
Yes, it is. Yes.
So how
That's why when you're dehydrated, don't you get a headache?
right.
Because the
Drying
main
out is putting pressure.
correct. The main component of blood is water, the plasma. Do you see the importance of normal blood pressure? When you're pumping blood to the brain, isn't it going against gravity, right? So it's pressure dependent for your brain to be nourished. And that's why when you're hypotensive, do you agree when you're hypotensive, you're not delivering nutrients, right? So you pass out. And that's why they also call hypertension silent killer. Because you have high blood pressure. You're still nourishing your brain. You're still doing whatever you want to do. It's still working. But you're hypertensive. It's very scary too. You can have a bleed. It's just, you're just not aware of it. Because your brain is still being nourished. Okay? The next, neuroglia that we're going to, do you have any questions on ependymal cells? The next neuroglia are the neuroglia you only find in the PNS, meaning not the brain and spinal cord. Okay. So, the Schwann cells. Schwann cells also myelinate neurons, so we already know what it does. It makes the myelin of the axons that are not found in the brain and spinal cord. So when you open up your cat, I'm going to ask you to look for one nerve, the femoral nerve, very obvious right here, it's very big. And you will say that this is being myelinated by this one. What's the function of myelin again? To facilitate the faster propagation of nerve impulse or electrical impulse. The other neuroglial cell you find in the PNS is called satellite cells. Look at, in your CNS, your brain and spinal cord, you have at least the cranium and the vertebral column protecting them. But the neurons, that's, you know that you have neurons outside too, right? So these neurons here, they're very prone to damage. They have nothing to protect them. So that's why you have the satellite cells. Look at what it says about satellite cells. See? It surrounds the cell bodies of the neurons in your PNS, which the cell body contains the nucleus, the organelles there. So that's how it protects it, even though there's no bone. Okay? Do you have nervous tissue in your dorsal body cavity? Yes. How about in the ventral body cavity? How about outside of any body cavity? Yes or no? Yes, you do. Isn't this outside, right? So even inside or outside body cavities, you will have nervous tissue. And that's where the satellite cells are very important in protecting them. Okay? You have any questions? That is those are neuroglia, and they have nothing to do with generation of action potential. Action potential generation or electrical impulse or nervous impulse, what else do they call it? That's just the main function of the neuron. Okay? Which we're going to study on next Thursday. What I want for you to do now is to, in addition to the worksheet, the take-home practice test that I hope that you all of you have, I want you to pair up with someone or no more than 2, 4, 6, 8, 10. No more than 2 or 3 or so I want partners, but then you can talk to your other neighbors, no more than 2 partners. Do you know what I mean? So I have another worksheet for you. Bio 241, like I said, you're expected to know your muscles and your bones. That's Bio 241 knowledge.